Lightning flashes over Long Island, briefly outlining a tall lattice tower. Waves crash along the rocky shore as rain drips along the wooden beams. Inside a low brick laboratory, papers and diagrams fly about in the turbulent air. A gaunt figure with a hawk-like profile stands by a window, staring out at the storm. Nikola Tesla is in his early 40s, his eyes alight with inspiration. He wipes ink from his fingers and picks up a coil of copper wire, murmuring to himself about resonance. Around him are glass tubes, humming generators, stacks of patents, and mathematical notebooks. There's a blueprint pinned to the wall, a 187-foot tower topped with a copper dome, trailing lines that plunge deep into the earth. Beyond the thunder, we hear a chorus of distant voices, millions of people plugging in lamps, turning on radios, lighting cities. In this dark workshop, Tesla vows to free them from wires. What followed would divide his legacy in two. One side preserved in records, contracts, and court decisions, the other shaped by rumor, speculation, and belief. We begin with the official story. Nikola Tesla grew up in what is now Croatia, the son of a Serbian priest and an inventive mother. By his 20s, he was working for the Continental Edison Company in Paris, repairing dynamos. In the 1880s, he emigrated to the United States and soon devised the alternating current induction motor that revolutionized power distribution. But alongside his practical work, Tesla nurtured a dream: to send electricity through the air and earth without wires. In 1897, he patented a system of electrical transmission of power that proposed using the conductive properties of the planet itself. He imagined the Earth as a gigantic conductor and the atmosphere as a waveguide, capable of carrying vibrations of electric energy around the globe. To test his ideas, he needed space, and so in 1899, he traveled to Colorado Springs. The Colorado Springs lab sat on a barren hilltop east of the city. Tesla built a barn-like structure and installed the largest resonant transformer coil ever constructed, more than 49 feet across. From this massive coil, he generated artificial lightning up to 135 feet long, sending arcs of blue fire crackling into the high plains night. The experiments electrified the environment. Sparks jumped from the ground to the shoes of passers-by. Water taps threw off bolts, and horses in a nearby stable bolted in panic as currents coursed through their metal shoes. Observers recalled butterflies swirling in circles with glowing halos around their wings. Tesla believed he had proved that the Earth could conduct electrical energy and that tuned receivers placed miles away could light bulbs without wires. The press dubbed him a wizard. Investors saw him as both genius and eccentric. Tesla was not alone in pursuing wireless communication. In England, Heinrich Hertz had shown that radio waves existed and obeyed Maxwell's equations. Young Italian entrepreneur Guglielmo Marconi combined existing components, spark coils, tuned circuits, and aerials to send Morse code across increasing distances. By December 1901, Marconi received the letter S across the Atlantic, launching a media frenzy. Tesla responded with confidence. He claimed his oscillators produced far more powerful waves and that Marconi was using his patents. Nevertheless, capital flowed to Marconi's telegraphy company, whose simple apparatus promised profits. Other inventors explored alternative sources of free energy. In Salt Lake City, engineer Thomas Henry Moray claimed to have discovered a mysterious Swedish mineral that, when connected to an antenna, produced electricity. In the 1920s, he demonstrated a device that lit dozens of lamps and ran a heater without any apparent power source. Newspapers wrote about Moray's radiant energy, and skeptics demanded to know how it worked. Having convinced himself that wireless power was possible, Tesla set out to build a commercial transmission station. Financier J.P. Morgan backed the plan with $150,000, viewing it as a means to dominate global communications. Tesla purchased 200 acres in Shoreham, Long Island, and by summer 1901, construction of the Wardenclyffe Laboratory began. The centerpiece was a tower that would dwarf nearby trees, 187 feet tall with a hemispherical copper cupola weighing roughly 55 tons. From the tower's base, iron pipes were driven 300 feet into the earth to create a deep electrical ground. Beneath the tower, workers excavated a 120-foot shaft lined with wood and steel. From its bottom radiated 4 100-foot tunnels. Tesla boasted that the whole globe would quiver when his machine operated. Inside the accompanying brick building, Tesla installed an array of equipment: coal-fired boilers, Westinghouse generators, transformers, glass-blowing furnaces, remote-control boats, and vacuum tubes. The site buzzed with activity, but Tesla's ambitions exceeded his funding. As 1902 turned to 1903, he wrote increasingly urgent letters to Morgan, arguing that he could transmit not only telegraphy but also electric power across the Atlantic, rendering cables obsolete. Morgan, now more interested in Marconi's thriving company, refused further money. When Marconi successfully transmitted messages with far cheaper apparatus, investors shied away from Tesla's complex and unproven system. In July 1903, days after Morgan's final refusal, locals reported that the Wardenclyffe Tower blazed with bright flashes that lit up the night sky. Tesla never explained what he was testing. Soon after, construction slowed and the property grew quiet. By 1906, Tesla's finances were in tatters. His alternating current patents had expired, cutting off royalty income. Key supporters died or moved on. He mortgaged Wardenclyffe to pay his hotel bills, and unable to repay, watched as creditors closed in. In 1917, to settle debts, the tower's wooden frame and copper cupola were sold as scrap metal for a fraction of their cost. Tesla's dream of a global energy grid ended without a single home being powered. He spent his later years working on smaller inventions and writing about theoretical ideas. During the Colorado Springs experiments, he had detected repetitive radio signals that he interpreted as intelligently controlled. In later articles, he speculated about communications from Mars or Venus, encouraging speculation that he had stumbled upon extraterrestrial transmissions. Today, the dream of transmitting energy through the air lives on in charging pads, laser power links, and proposals to beam solar energy from space. Before diving into alternative interpretations, we must lay out what supporters of Tesla's vision claim. These believers argue that clues scattered across history show that free energy via wireless transmission is real, and that it has been deliberately suppressed. These include the apparent sophistication of Tesla's designs, reports of successful demonstrations by him and other researchers, and tantalizing accounts of mysterious signals and missing documents. Supporters insist that Tesla perfected a method of broadcasting electricity without wires, and that powerful interests shut it down to preserve profits from coal and copper. They point to Wardenclyffe's design. The tower's iron pipes were driven deep into the earth to create a conductive connection, and Tesla spoke of making the whole globe quiver. Legend holds that during a stormy night in 1903, the tower erupted with brilliant flashes visible for miles. Believers say these were successful tests of the system, and that soon after, financial support vanished and the tower sat idle. They note that Tesla's Colorado Springs experiments electrified lamps and caused power outages miles away. To them, the sudden withdrawal of J.P. Morgan's funding especially after Marconi's simpler telegraph gained traction, suggests a deliberate effort to stifle a technology that could have provided free energy. Proponents also recount stories of researchers who tried to continue Tesla's work and met obstacles. They cite Thomas Henry Moray's demonstrations in the 1920s and 1930s, where a device reportedly drew energy from the environment and powered multiple appliances without conventional input. Moray claimed his invention tapped a radiant energy sea, possibly cosmic rays. Witnesses, including engineers and government officials, saw lamps burning and motors running in his Salt Lake City laboratory. Yet Moray refused to reveal the device's secret element, said to be a special Swedish mineral, and failed to secure a patent. Supporters emphasized that his lab was later raided and the device destroyed, implying suppression. Finally, believers connect Tesla's supposed breakthroughs to modern hints of free energy. They note that mainstream science eventually demonstrated microwave power beaming and resonant wireless charging decades after Tesla's death. To them, these successes validate his original concept and hint that he was far ahead of his time. The narrative concludes that the combination of technological promise, corporate interests, and political pressures led to a deliberate cover-up of Tesla's wireless power project. Beyond Tesla, many researchers have pursued wireless and radiant energy. Believers cite these efforts as proof that such technologies are feasible. Thomas Henry Moray remains a favorite example. Moray would take the device into remote locations, mountaintops, deserts, and even a sealed container at the bottom of a lake, to prove it was not drawing power from hidden wires. In these public demonstrations, the apparatus lit banks of light bulbs, powered heaters, and ran motors. Moray believed cosmic rays carried energy that could be captured. He called the device his cos-ray receiver. Skeptics pressed him to reveal the secret component, but he refused, claiming it would be stolen or suppressed. Another figure frequently mentioned is William C. Brown. In the 1960s and 1970s, Brown, working at Raytheon, developed rectifying antennas, rectennas, that could convert microwaves back into electricity. With NASA's Richard Dickinson, Brown demonstrated microwave power beaming across a laboratory with over 50% efficiency. In another test, they transmitted more than 30 kilowatts of power over a mile to a receiving antenna. The demonstrations were part of a NASA Department of Energy project to evaluate solar power satellites beaming energy down to Earth. Believers interpret these experiments as proof that high-power wireless transmission is practical and that Tesla's dream only needed modern components to succeed. Finally, contemporary academic research provides fresh evidence. In 2007, an MIT team led by physicist Marin Soljacic announced Ytricity, using magnetically coupled resonant coils to transfer energy wirelessly. They lit a 60-watt bulb from a coil 2 meters away, even when obstacles blocked the line of sight. Although the experiment used resonant coupling rather than earth conduction, supporters see it as validation that efficient wireless power is achievable. Combined, these modern endeavors form a bridge between Tesla's pioneering work and today's innovations, reinforcing the belief that humanity stands on the cusp of reclaiming a suppressed technology. The final claim stems from Tesla's own words. During his year in Colorado Springs, Tesla wrote to a reporter that he had detected strange, repetitive signals on his receiver that he interpreted as intelligently controlled. In later statements, he said the signals appeared in sequences of 1, 2, 3 pulses and speculated they might be messages from Mars or Venus. Newspapers sensationalized the idea that Tesla was receiving extraterrestrial communications. Believers interpret this as evidence that he had tapped into unknown communication channels or even alien energy sources. They argue that when Tesla died in 1943, the US government confiscated his papers and classified them, possibly hiding discoveries involving non-human technologies. Interestingly enough, one of the engineers called upon to analyze Tesla's works was John G. Trump, the uncle of none other than Donald Trump. Stories about secret dossiers add to the mystique. Some claim that Tesla's research was quietly developed into directed energy weapons or classified communication systems. They link these rumors to modern military research projects, suggesting a hidden continuity from Tesla's experimental coils to contemporary high-frequency arrays. The destruction of Moray's device is woven into this narrative. If Moray had tapped an unlimited energy source, powerful forces might have intervened to keep it from public use. Together, these elements form a tapestry of intrigue that stretches from Tesla's Colorado cabin to the halls of modern defense agencies. Having explored the believer's claims, it is clear that the story of wireless energy is fertile ground for speculation. But how will it hold up when we confront these assertions with skeptical analysis, separating documented fact from legend? Skepticism is essential when evaluating extraordinary claims. Historians, scientists, and engineers have examined Tesla's work and that of other wireless energy proponents. Their assessments provide context, highlight practical limitations, and debunk myths. Tesla's Wardenclyffe Tower was a marvel of ambition, but not of practicality. To achieve global power transmission as he imagined, the tower would have required a continuous supply of hundreds of kilowatts. The underground pipes and tunnels were intended to create a resonance between the tower and the planet, but no evidence shows that Tesla ever achieved such resonance at useful power levels. Contemporary accounts suggest that the flashes seen in 1903 were demonstrations to impress investors rather than proof of successful broadcast energy. Financial backers, including J.P. Morgan, withdrew support because Marconi's simple radio telegraphy delivered profitable results at a fraction of the cost. Engineers note that even today, wireless transmission suffers significant losses over distance. In Tesla's time, the technology to generate and control the necessary power did not exist. Economic realities also undermined the project. Copper mining, telegraph cables, and emerging power companies formed powerful industries. However, they thrived because their systems worked, not necessarily because they suppressed alternatives. Wardenclyffe failed to attract new investors because it lacked a clear business model and because its inventor refused to compromise on scale or design. While it is tempting to imagine a conspiracy of Edison and Morgan against Tesla, the documented correspondence reveals a more mundane story of missed deadlines, technical uncertainty, and exhausted capital. Modern historians emphasize that unproven ideas often fail, not because of sabotage, but because they are not yet feasible. The feats of Moray, Brown, and Solzhenitsyn show both the promise and the limits of wireless energy. Moray's device remains an enigma. He never disclosed the identity of his Swedish mineral, and no independent researcher has replicated his results. Scientists suspect his demonstrations may have drawn on hidden batteries or exploited high-frequency radio energy inadvertently captured from nearby sources. Without verifiable disclosure, his claims sit outside the realm of science. Brown and Dickinson's microwave tests achieved impressive efficiency, but the hardware, large antennas, and precise aiming made them suitable only for specialized applications like solar satellites. Even today, microwave beaming is limited by atmospheric absorption, safety concerns, and cost. It is not suppressed, it is simply challenging. MIT's Witricity experiment excited technologists, yet it was never intended to deliver grid power. The setup transferred 60 watts over 2 meters, enough for a light bulb or a laptop. The method relies on near-field magnetic resonance, effective at room scale but inefficient over long distances. This technique is now used in wireless chargers for phones and electric toothbrushes. Engineers caution that while incremental progress continues, no existing method can deliver megawatts over miles without massive infrastructure and significant losses. The physics of electromagnetic waves and energy conservation impose constraints that conspiracy theories overlook. Tesla's claims of signals from another planet came at a time when radio was in its infancy. In 1899, Marconi and others were experimenting with long-distance transmissions. It is plausible that Tesla's receiver picked up Morse code or experimental pulses from other researchers. Subsequent analyses suggest that the 1, 2, 3 pattern he reported resembled test signals used in early wireless experiments. The idea that he received messages from Mars ignited the public imagination but lacks supporting evidence. As for secret papers, the FBI did seize Tesla's belongings after his death, but most of his technical notebooks were eventually released to his family or archived. The U.S. government declassified many documents relating to his work. None describe a functioning free energy machine. Stories linking Tesla to modern directed energy weapons extrapolate from his interest in high-frequency currents, but ignore the decades of independent research that followed. Moray's destroyed device may have been the victim of sabotage, but alternative explanations, such as mechanical failure or theft, are equally plausible. In the absence of verifiable documentation, tales of extraterrestrial signals and hidden energy sources remain appealing legends rather than credible history. The skeptical perspective does not diminish Tesla's genius. It situates his achievements within the limitations of his era. It reminds us that scientific progress is iterative and that extraordinary claims demand rigorous evidence. The myths surrounding wireless energy often flourish where documentation is scarce and hope is abundant. Having weighed evidence and counterpoints, we step into the realm of speculative ideas. These theories aren't statements of fact, but frameworks for considering what might have been and what might still be possible. This theory proposes that Tesla was simply too far ahead of his time. He grasped principles of resonance and global conduction that others could not yet comprehend. Without modern materials and electronics, he could not bring his ideas to fruition. In this narrative, had Tesla been born a century later, he might have designed robust resonant networks like those seen in today's wireless chargers and laser power beams. The theory invites us to imagine Wardenclyffe completed, a global system in which towers synchronize with Earth's natural frequencies, providing clean energy to anyone with a tuned receiver. Skeptics of this theory acknowledge that even with modern technology, Earth conduction transmission would face enormous technical obstacles. Yet the thought experiment highlights how visionary ideas sometimes require generations to mature. Thomas Henry Moray believed that space is filled with an ocean of energy that can be tapped with the right materials. This theory builds on his concept, suggesting that cosmic rays, vacuum fluctuations, or some yet unknown medium carry vast amounts of power. Proponents imagine devices that resonate with this energy, drawing it down like a well taps groundwater. In this scenario, early inventors such as Tesla and Moray glimpsed the possibility, but lacked the scientific framework to harness it fully. They faced opposition from industries built on extractive fuels, which led to suppression. Critics argue that modern physics, especially thermodynamics and quantum field theory, leaves little room for such an inexhaustible energy reservoir that can be freely harvested. However, the allure of an energy sea persists. inspiring both legitimate research into zero-point energy and fringe movements seeking the next breakthrough. Rumors have long linked Tesla's work to secret military projects. He once proposed a teleforce weapon, a particle beam generator that could destroy enemy aircraft. In this theory, aspects of his wireless power experiments were adapted for military purposes. The high-frequency currents and pulsed discharges he developed could have informed later research into directed energy weapons and over-the-horizon radar. The story suggests that government agencies quietly acquired his notes after his death, incorporating them into classified programs. Supporters point to projects like the High-Frequency Active Auroral Research Program, HARP, and modern laser weapons as possible descendants of Tesla's inventions. While there is no public evidence that Tesla's wireless power system directly led to such technologies, the theory underscores how innovations can migrate from civilian to military domains and become shrouded in secrecy. The most grounded thought experiment posits that we are on the cusp of realizing Tesla's dream, but through incremental advances rather than suppressed breakthroughs. Magnetic resonance coupling, microwave beaming, and laser power links are no longer speculative. Companies and research agencies are experimenting with powering drones, electric vehicles, and remote sensors without wires. NASA and other organizations are studying space-based solar arrays that could beam energy to Earth, reducing reliance on fossil fuels. In this vision, Wardenclyffe was a prototype that failed, but its spirit lives on in modern labs. The revolution will not arrive as free energy delivered to all corners of the planet. It will emerge through practical applications that complement existing grids and gradually expand our capabilities. The theory highlights the continuity between Tesla's vision and today's engineering challenges. These thought experiments illustrate the spectrum of possibilities: romantic, conspiratorial, and realistic. Each invites us to contemplate not only the science, but also the social and economic forces that shape technological adoption. They remind us that history is not inevitable. It is the product of choices, opportunities, and sometimes luck. Standing amid the ruins of Wardenclyffe today, one sees only a concrete foundation and the remains of tunnels that once promised to shake the earth. Yet Nikola Tesla's dream echoes in every cordless charger and every talk of beaming solar energy from orbit. He imagined a world freed from the tyranny of wires and monopolies, where energy flowed like air. Whether his vision was thwarted by conspirators, constrained by physics, or simply ahead of its time, it continues to inspire engineers and mystics alike. As we push the boundaries of wireless power in our own era, from drones fed by laser beams to near-field chargers in our kitchens, we do so standing on Tesla's shoulders. In the end, the story of wireless energy is less about hidden technologies than about human ambition. It reveals how difficult it is to realize transformative ideas in the face of limited resources, competing visions, and physical realities. It also shows that no idea truly dies. The dream of transmitting power through the air has lived for more than a century, and it may yet become reality. Just imagine, no need for a phone charger, no need for cable management, and no need to pay for increasingly expensive electricity bills. Wouldn't that be a sight? Until then, we look at the stormy night in 1903, at the tower flashing over the dark Atlantic, and wonder what might have been. If you enjoyed this journey into Tesla's wireless dream, please like, comment, and subscribe. Tell us, do you think free energy was suppressed, or was Tesla simply ahead of his time? Join the discussion below and help keep the curiosity alive. All of this helps the channel grow, and it means I can keep bringing you stories that change the way we see history and reality itself.